So that is determining oxidation states and electrons. Okay, let's move on. So now we're going to do some ranking by electronegativity. Okay, so we're going to rank each of these atoms by electronegativity, and at the 15-minute mark right now, so it's going to be a bit of a long video, but hopefully we can get through everything. So we're going to rank everything by electronegativity, and what we need to do that is the periodic table. So let's consider what trends we're talking about. What the trend we're talking about in electronegativity is this trend, right? It's the trend that says that as you go this way in the periodic table, things become more electronegative. So let's look at what that means. Okay. So we have oxygen, fluorine, nitrogen, chlorine, iodine, arsenic. Okay, so if we can put these maybe side by side, might be better. If we put these side by side like this, like that. I'm not sure if this part of it is visible right now or not. Nitrogen, oxygen, fluorine, chlorine, iodine, and where's arsenic? Arsenic's over here. Okay, so arsenic is a very clear, like, one that's not going to be very electronegative. Okay, it's first of all a metalloid. Second of all, it's pretty far this way. So this is going to be the least electronegative. So let's say that that's going to be 6. All right, so we're going to say 6 is the least. Okay, 6 in its electronegativity. Now, nitrogen, oxygen, and fluorine hydrogen bond, and that means that they're the 3 most electronegative atoms. So the trend going this way is much stronger than the trend going this way. So let me tell you what I mean by that. What I mean is because it goes in order from most electronegative to least electronegative, fluorine, oxygen, nitrogen, right? Fluorine is the most electronegative, always. You should just remember that. Fluorine is the most electronegative. So we have fluorine, and then oxygen comes next, so that's 2, and then nitrogen, 3. Although chlorine is directly underneath fluorine, it's still not as electronegative as nitrogen. Okay, so that's why what I mean by the trend is stronger horizontally than it is vertically. And so if we look at chlorine, that will be 4, right? So chlorine is over here. Iodine's all the way down there, so that's going to be 5. Okay? And that's going to be 6. So that's electronegativity. Just remember, nitrogen, oxygen, fluorine are the most electronegative elements. And if you can remember that, then you can also remember that the trend is stronger horizontally, because we don't say that chlorine or bromine, chlorine, and fluorine are the most electronegative atoms. So if you can remember that, maybe that will help you remember the trend better. All right? So that's electronegativity. Again, you can let me know if you have questions about that. Atomic radii and ionization energy. I decided to group these together because I want to show you a cool trick that you can use, or, well, not really a trick, it's actually just logic and science. But it's a way for us to look at ionization energy as kind of a function of radius, okay? Because they're very related to each other. So let's consider these 4 atoms that I have here. So I have, so we have chlorine, fluorine, bromine, and sulfur. So let's find out where those are. We have chlorine, fluorine, bromine, and sulfur. So we have these, and they're all next to each other. And I did that on purpose because that's the way we do it. So, because that's the way that you really understand what's going on. So if we're saying what is the biggest, let's start off with radius. Okay, so we'll do radius as the first column there. So we're doing what is the biggest. The biggest thing is going to be the atom that is the lowest down. Okay, and what that means is it's the farthest down the group. And that's going to be bromine. Okay, so bromine will be the largest because it's the farthest down. So let's say that, I guess let's say, no, we'll just do 1. Biggest radius. Did I do that on the last one? Doesn't matter. 1 is the biggest, so this is big. Okay, fluorine is all the way on at the end. Remember we said that cesium is the largest atom and fluorine is the smallest atom. So fluorine is the smallest, and the trend goes this way, and atomic radius gets bigger that way. So if we look at fluorine, we could say this is the smallest. This will be 4. Small. And then we have sulfur and chlorine, which are kind of in the middle. Okay, so chlorine is going to be very slightly larger than sulfur. And the reason for that is because it's very slightly farther down. And that means it has 1 more electron, and so its radius will be very slightly larger. Okay? In reality, they're going to be pretty similar in size. So this is almost a tie, but I would say that chlorine is probably tiny bit bigger. Oh wait, sorry, this is supposed to be 2, and this will be 3. Okay. Yep. And that's atomic radius. So if we think about what a large atomic radius means for ionization energy, if you have a nucleus here, and then you have your electrons at this distance, then it might be pretty easy for you to kick off an electron, which is what ionization is, to lead to a positively charged nucleus. But if your atomic radius is huge, if it's gigantic, or I'm sorry, it'd be very hard to get this electron off. I'm sorry. It would be hard to get this electron off because you're close to the nucleus. It's small, right? So there's a strong attraction between these two, a Coulombic attraction between those two. But if the radius is really, really big, then a big radius is going to have a larger distance between the two. And so this will be easier to ionize, okay? And so the ease of ionization depends directly on how big the atom actually is, because that's how tightly the nucleus will hold together those electrons. Okay, so let's consider what this means in this context up here. So we're saying bromine is the biggest. So that means that it's going to have the lowest ionization energy. And so we'll say 1 being low, right? Because it's an energy, so it's low, right? Low or high. Excuse me. So it's going to have a low ionization energy because it's so big. Now we said chlorine was the second largest. And because chlorine is the second largest, it's going to have, again, 2 very kind of low. Okay. Sulfur will be 3, where we have a kind of small radius. So this will actually be kind of high. And then 4, the fluorine has a very, very small radius. So this will be high. Okay, so it will require, so fluorine has a very high ionization energy. Sulfur has a slightly lower ionization energy. Chlorine has an even lower ionization energy, and bromine is pretty easy to ionize. Okay, and one really cool way that you can kind of look at this is that this can exist as an ion, and this can exist as an ion too. Okay, and that's because it has gained an electron, but that's actually a different topic, so we're not going to talk about that today. Now, technically, this one also does, right? And this one can too. This one can be sulfur 2 minus.